Hey guys, today I'm going to talk about some extraterrestrial possibilities, and more specifically, we're going to read out loud together this particular article, which is In the Hunt for Alien Life. This planet just became a top suspect, so really interesting and so captivating. Let's get into it. The mixture of gases measured in exoplanet K218b suggests it may have a global ocean beneath a hydrogen-rich atmosphere, and astronomers even spotted a tantalizing, though unconfirmed, sign of life. Recent observations made by the James Webb Space Telescope have revealed new details of the atmosphere of a distant planet called K218b. An analysis by a European team of researchers found an abundance of methane and carbon dioxide with very little ammonia, a combination that suggests the world could be a type of oceanic planet previously only theorized. K218b is located at the correct distance from a star that life is considered possible, and the new analysis suggests another compound, dimethyl sulfide, which is made by life on Earth, may also be in this watery world's atmosphere. Follow-up observations will attempt to determine if the compound is really there, and if it is present, additional work would be needed to rule out possible non-living sources of the gas. Even without life, K218b is helping reveal a whole new class of worlds that are bigger than Earth but smaller than Neptune. Nico Madhusudan, an astronomer at the University of Cambridge and lead author of the paper announcing the results, previously theorized that such planets could host liquid oceans beneath their atmospheres. He recalls seeing the data that show the presence of hydrogen and, even more revealing, methane and a lack of ammonia. Research suggests a large planet like K218b could only have that ratio of gases if the atmosphere were interacting with water below. We've been looking for methane in these low temperature atmospheres for a decade, and here we found it on the first transit. He says it was a eureka moment. In 2021, Mahusudan coined the word for these wet planets, Haitian words. It sounds romantic, but it just combined hydrogen and ocean in a portmanteau. In addition to being an intriguing type of planet we don't have in the solar system, these words are pragmatic to study. They are larger than rocky words, making it easier for a space telescope to measure them with remote sensors. Oh, so we have a new word here, I guess. It is pragmatic, which means dealing with things sensibly and realistically in a way that is based on practical rather than theoretical considerations. Basically, it means practical, down to earth, realistic, stuff like that. The Webb telescope scanned the planet during a period of 2.5-hour transits in front of its host star in January and April. The onboard instruments scrutinized the starlight passing through the planet's atmosphere, giving astronomers spectral clues that can be used to identify the gases present. Webb, with a cost at the time of launch $10 billion, is proving its worth to researchers as a tool to examine distant planets. Matt Husudan says one 5-hour transit observation with Webb provides more data than 8 combined observations with the Hubble Space Telescope, which would take years to accomplish. It is revolutionary. He says, where to look for life? There are two prominent schools of thought in the ranks of those hunting for alien life on exoplanets: those who expect to find it on a rocky world like Earth, and those who want to search worlds dominated by oceans. The new study provides tantalizing new clues about possible ocean worlds, and Webb has also turned its gaze to rocky targets. Earlier this year, the telescope observed the nearby Earth-sized planets TRAPPIST-1b and TRAPPIST-1c, revealing that they are probably bare rock without protective atmosphere of CO2, making life unlikely. The findings suggest rocky planets such as these, which orbit a type of cool dwarf star known for giving off flares, may not be suitable environments for living organisms. It is extraordinary that we can measure those, said Laura Kreidberg of the Max Planck Institute for Astronomy, are the scientists who studied the TRAPPIST-1 system in a statement. There have been questions for decades about how weather rocky planets can keep atmospheres. Webb's ability really brings us into a realm where we can start to compare exoplanet systems to our solar system in a way that we'd never have before. While the new study strengthens the case for the existence of Haikan words, there are still alternative explanations. The same data from Webb can produce slightly different results depending on the analysis is done, which scientists sometimes refer to as the data analysis pipeline. Fox have already shown that the retrieved abundances from GWST can be very pipeline dependent, says Sarah Horst, a planetary scientist at Johns Hopkins University who specializes in atmospheric chemistry and was not a part of the new study. Calculations required to make such a claim are highly sensitive to the amount of various molecules in the atmosphere. But Hosedan agrees that more work needs to be done to confirm the results and says that a team from NASA Jet Propulsion Laboratory has time reserved to scan the planet with GWST later this year to gather more data. This is the start of a long road, he says, but an exciting one. Ocean planet extraterrestrials, water-rich planets like K218b are good candidates in the search for alien life. After all, it's the medium that enabled Earth to flourish. But even a planet with a liquid ocean and carbon-rich atmosphere isn't guaranteed to host organisms. It had to be the right size, temperature, and distance from its sun in what scientists call the habitable zone. K212 orbits K218b orbits a cool dwarf star in the constellation of Leo, a place in space that fits all the habitable zone criteria. But the planet's large size, 8.6 times Earth's mass, may work against life. Its icy interior may be wrapped with a thin ocean and atmosphere, so the liquid may be boiling away into space, possibly thwarting the ambitions of any aspiring life forms. But there's another clue in the Webb data, the possible presence of the molecule dimethyl sulfide. You find DMS in the Earth's atmosphere, produced by swarms of phytoplankton in the oceans. It's also the compound that makes a German-style Lega smell so pungent. As exciting as the possibility of this molecule on another planet is, there's a long way to go before the scientists know for sure. It doesn't really seem like there's a compelling evidence for DMS in the data, Horst says. Mahodan's 6-person team has time reserved early next year to use Webb's Mid-Infrared Instrument, or MIRI, a spectrograph that's optimized to detect DMS, to confirm or disprove its presence. Disprove its presence. Ask me this time next year, he says of the expected timing of the MIRI results. On Earth, no process is known to create DMS molecules but oceanic life. However, on a world like K218b, the conditions might be right for abiotic, non-living sources. Our understanding of sulfur-bearing chemistry is very Earth and Venus-centric, which are very different atmospheres from a hydrogen-dominated atmospheres like K218's. Horst says, we need many more theoretical calculations and laboratory measurements to understand what the different possible pathways are for creating and destroying DMS in an atmosphere. If DMS is detected on K218b, it's time for the theorists to really get involved. Matt Hodison says the job will be to run countless simulations of the planet's chemistry during its lifespan, trying to detect any possible pathway that would create the signatures DWST found without the presence of life. We don't have to prove it's a biomarker because it is one on Earth. Mahosidan says only once no other explanation is found can the case for a living ocean on the planet be made. The proof of alien life is often depicted with the discovery of Martian fossil, the receipt of an intercellular transmission, or even a verified extraterrestrial visitation on the White House lawn. But the actual moment that humanity finds out what we're not alone may be experienced by a solitary data cruncher, seated in front of a computer screen running complex organic chemistry models.